right, this is Algebra 1B Part 1. We're working on Unit 1, Lesson 3, which is still a review of Algebra 1A. We're going to solve some equations. We're going to solve one and two-step equations, and we're going to solve equations with variables on both sides. So this is by way of just a brief introduction, so you're going to get more details in the lesson, but hopefully this gives you a good idea of what you're going to learn in this lesson. All right, so here let's go ahead and get started. An equation is a mathematical expression that is set equal to another mathematical equation. Well, what am I spelling? Equation. All right, and so, for example, x plus 3 is an equation. Okay, I want to introduce you to some of the steps we use in solving equations. Principle number one is we want to get the x alone. Get the x alone. Okay. Another way to interpret that is this x wants to be by itself, but it's got this pesky 3 sitting here I'd like to get rid of, right? I'd like to get rid of the 3 so that it's all by itself on its own side of the equal sign. Okay. That introduces principle 2. To get x alone, to get rid of those pesky neighbors, we need to do the opposites. Do the opposite operation. The technical name is inverse operation. The opposite of adding is subtracting. The opposite of subtracting is adding. The opposite of multiplying is dividing. The opposite of dividing is multiplying. Okay, so in this case, I'd like to get rid of the plus 3s. So I'm going to do the opposite of adding 3. I'm going to subtract 3. That's the principle there. That introduces the third principle. We can't just willy-nilly go adding and subtracting and multiplying and dividing to just one side of the equation. We require balance. That is, anything I do to one side of the equal sign, I must also do to the other side of the equal sign. Okay? So we're getting x alone. We're doing opposites to get rid of things. And we're balancing it. So if I subtract 3 from the left of the equal sign, I subtract 3 from the right of the equal sign as well. Okay? And let's see what we get. Plus 3 and minus 3, a positive 3 and a negative 3. If I have $3 and you take $3 from me, I have nothing, right? So that is x. Now I could write plus 0, but there's no need because plus 0 doesn't do anything. So I'm just going to write x equals 0 minus 3, negative 3. Okay? So hopefully that makes sense. That's doing a one-step equation. And then we can do the same if it were multiplication, subtraction, and division as well. All right? We just do opposites to get the equation alone. So let's do a two-step equation. Okay? Oh. Two-step equation. Okay, and this is going to add one more layer to our 3 steps here. So let's say we have 2x plus 5 is 11. Okay. Now we have a little bit of another problem. We've got x here that we'd like to get alone, but x now has 2 neighbors, a 2 and a 5. And the question obviously comes up, which neighbor do I get rid of first? Well, I like to call this the onion principle. In what way do you peel an onion? Do you peel the inside layer off first, or do you peel the outside layer off first? And the answer is you peel the outside layer off first. This is another way to think of it is in a football game when there's a fumble and all the linebackers pile up on top, all the football players pile up on top of the ball. Referee blows his whistle and tells him to get off so he can determine who has the ball. And meanwhile, they're struggling and fighting for the ball underneath and the bottom of the pile. But who has to get off the pile first but the last person that got on, right? You can't take the bottom person off first because he's got everybody else piled on top of him. Same thing here. PEMDAS, order of operations, says this is x times 2 plus 5, right? So the plus 5 is the last one that was added on, so it goes first. Okay? So the way I call this reverse order. Reverse order. When there's more than one thing to get rid of, we do them in reverse order, peeling the onion, so to speak. So we get rid of addition before we get rid of multiplication, because you remember PEMDAS? Please excuse my dear Aunt Sally. Okay, multiplying and dividing comes before adding and subtracting, but when we're solving an equation, we do it in reverse order. We work bottom up. Okay, adding and subtracting is gotten rid of before multiplying and dividing. So we're going to get rid of the plus 5. The opposite of plus 5 is minus 5. Balance requires that if I subtract 5 from the left of the equal sign, I need to subtract 5 from the right of the equal sign. So subtract 5. 5 minus 5 is 0. So I get 2x equals 11 minus 5, or 6. Now we're going to do the opposite of times 2. When there's no symbol between a variable and a number, then the operation is times, multiply. The opposite of multiply is divide. If I divide 2 on the left, I divide 2 on the right. 2 divided by 2 is 1. 1 times x is x. So we get x equals 6 divided by 2, or 3. Right? So that's a two-step equation. Let me do one more example. I'll leave this one on the screen, but I just want to show you that it works for all two-step situations here. I'm going to say x minus 3 divide 4 equals, let's see, let's see if I can make this work. I'm going to say 11. Yeah, that'll work. That'll work. Okay, so here we go. Notice, by the way, I put the x on the right side of the equation. That may mess you up because you think, oh, that x has to go on the left. It actually doesn't. We don't really care what side the x is on. So the x can be on the right side too, and we just want to get it alone, right? Now, we're going to look at, well, we want to get the x alone. We want to get rid of the 3 and get rid of the 4, so which comes off first? Now, you might be thinking, oh, divide and then subtract. Subtraction comes after division normally, so I'm going to get rid of the subtraction first because it's reverse order. But you got to be careful. Remember, there's a parentheses implied in a fraction bar. Parentheses. And so that means the subtraction comes first, then the division by 4. So reverse order says I'm going to get rid of the 4 first. And the opposite of divide 4 is times 4. Times 4. Okay? And I'm going to do that to both sides using the balance principle. Okay? 11 times 4 is 44. Okay, 4 divided by 4 cancels out, leaving 1, and 1 times x minus 3 is x minus 3. Okay, and we can drop the parentheses now that the 4 is gone. Now we want to get rid of the minus 3. We do opposites to get rid of. Opposite of minus 3 is plus 3. If I add 3 to the right, I add 3 to the left. Okay, and 44 plus 3 is 47. So x is 47. So that's a couple of examples of how to solve by undoing with more than one step. Okay, there's one more type of problem we're going to look at, and that is a problem where there's an x on both sides of the equal sign. Okay, and that happens sometimes here. So let's do that here. Let's say we've got 5x plus 4 equals 8x minus 6. Now I'm making up numbers, so it might not come out to nice whole number answers, and that's all right. Fractions are numbers too. All right, so here's the new step here. Okay, the fifth thing here is we start, if there's an extra x, okay, an extra x, we get rid of the extra x first, right? The extra x. There's an x on both sides of the equation. And so what I do here is I determine which is bigger, which has the bigger coefficient, 5x or 8x. And 8x is bigger, so I'm going to get rid of the other one. I do that so that I end up with a positive coefficient on x, right? It would be technically okay to subtract 8x from both sides, but I'm going to subtract 5x from both sides because it is the smaller of the two and will result in a positive number. Okay, so 8x minus 5x is 3x. Like terms, just 8x's, take away 5x's is 3x's. Bring down the 6, bring down the 4. 5x's, take away 5x's is no x's, so the x's are gone. Okay, now reverse order here. Multiply and subtract. Subtract comes after multiply, so I'm going to get rid of the subtract first because it's reverse order. Opposite of minus 6 is plus 6. If I add 6 to the left, I add 6 to the right. Negative 6 plus 6 is 0. 3x is 4 plus 6, or 10. Yeah, and see, it didn't turn out nice, but that's okay. Fractions are numbers too. The opposite of multiply is, divide, so I'm going to divide both sides by 3. 3 divided by 3 is 1. 1 times x is x, and the 3's cancel. And x is 10/3. Now you can write 10/3. That's an improper fraction. Nothing improper about it, actually. In algebra, we prefer them. 3 goes into 10 3 times. 3 times 3 is 9, so there's 1 left over. So this is also 3 1/3. Okay, what I would not put is 3.3. Okay, because 3.3 is not exactly right. It's 3.333333 forever to be exactly right. So leave it as an improper fraction if given a choice. If the question asks you to round it to a decimal place, you can do that. But do be aware you're rounding it and you're not giving an exact answer anymore. All right, that's it. That's it for this lesson here.